So in significant figures also there are certain rules, and I think even if I don't write down the rules, you will be able to guess it. Okay. Maybe I can just probably I can just make a table. Okay. So in general, if I just write down significant figures, okay, what we have is generally all reliable digits. Okay, reliable digits plus the first uncertain digit, first uncertain digit. Okay, so you might ask that what does that mean? So in general what happens is that if you're just taking any kind of numerical value, okay, for example, let's say I will take this 24.567 meter. Okay, so this basically has got reliable digits up to 0.56. So 2 4, just don't take it as 2456, just say 2456. All these digits are basically considered as reliable. Okay, so if there is any kind of fluctuation, there will be the last digit, and that is basically called an uncertain value. How do I use it, or where is its application? So when you basically look into a weighing machine which is very sensitive, let's say, okay, in labs you usually find it. If you have done your chemistry experiments in undergraduation, you might have already used a weighing machine, okay, in the lab, and there you know that the last digit keeps on fluctuating. So usually when we do the measurement, we usually don't consider this last digit. Okay, we're just going to consider up to 224.56. Okay, so if you just take any kind of value, let's say 43.5 kg, we usually call that it has got three significant figures. So in significant figures we do consider the last digit, okay, the uncertain value as well. So it has got five significant figures. Okay, and that is what is the importance of significant figures. Okay, so there are certain rules, and probably I will just take some example to tell you the rules. Okay, so maybe I can just, okay, so maybe this is rule number. Okay, so I'll take rule number here, and then might be I can take an example here. Okay, and then I can just write down what is the significant figures, how many significant figures are there. Okay, so let's write down rule number one. I'm just not going to give you the statement. I think this is very trivial. Okay, you understand this. So let me take this 4 2 point, let's say I'll take a bigger number. Okay, 9 6 4 3 2 1. So you can just count the numbers here. It's simple, 8. Okay, so the number of significant figures are 8. Okay, so significant figures are 8. So you know, all the rule says that all non-zero digits are significant. You don't have any zeros involved here. So anyway, this is very simple. Okay, number 2, let me just take this as 4.0920034. Now you see there are some zeros involved. Okay, but then do we consider them significant? Yes, because they are between two values which are non-zeros. Okay, so 1 2 3 4 5 6 7. So I will just have 7 significant figures. Okay, so all zeros between non-zero digits are significant. That's rule 2. Okay, so this is very simple. You can easily remember it if you just remember one example. Okay, and then if you just take something like this. Okay, this is only 2, because you know these zeros are terminating values. These lies at the end, and they are not covered by another value which is non-zero. Okay, so terminal zeros without a decimal point are not significant. There is no decimal point, is 47,000. The 3 zeros are not considered as significant, so just put the value as 2. Okay, please understand this, that if we write down something as significant figures, so there are 2 significant figures, does not mean that the original example or the original value will be having only 2 digits. It might be having some zeros involved. Okay, so it's not that it is discrediting the importance of 0. No, it's not. Okay, it's how we actually identify significant figures. Okay, because you know, later on, I think you've already done it. You can already write it down as 47 into 10 to the power 3. So you can do it that way. So 47 is something which is actually dictating the powers. Okay, so that is important. That is where we take it. Okay, and then if we, yeah,
Sir,
yeah.
sir, can we, and zero is not considered as the significant figure?
It depends on what is the position of zero.
Okay, sir.
So what happens is that if we are basically taking a zero after the decimal point, we basically consider it to be significant. But if there is no decimal point as such and it is just a whole number, we basically don't consider zero as a significant figure. That's how the rule works. Okay. So you have to consider this, that if you see 0 here, this is considered significant because 0 is trapped between two values which are non-zero. Okay, so this is actually considered as significant. But here what happens is it's at the end and there is no decimal point as such, so the rule says that these zeros are not significant. They are considered in the value, but they are not considered as significant figures. Okay, so that is important. One more rule.
Sir,
Okay, number 5. Number 5 is something which is for a value which is less than 1. Okay, so less than 1, let me just take an example, 0.0154. So if you take this example, since it is less than 1, you are considering only these three as significant figures. Okay, so what happens is, for zeros on right of a decimal point but left of the first non-zero digit are not significant. So basically we are just going to take it as 3. So these are the 5 rules that you should remember. I think these first 2 rules are very easy to remember. Please try to make a separate space for these 3 to remember. Okay, these 3 are actually a bit confusing. Okay, this is how the rule works. Okay,
sir,
so this is important. Yeah.
sir, just suppose the number is 409.
Mm-hmm.
Then
Three
can
significant figures. If a value is 409, this 0 is trapped between two values which are not 0. They are non-zero. Okay, so the number of significant figures would be 3. Okay, so this is this rule, actually, this rule. It might have a decimal point, it might not have a decimal point, but if it is trapped between two non-zeros, it is always considered as a part of significant figure. Okay, so significant figure and power plays a very important role. Okay, because if we are basically considering a change of unit, it does not change the significant figures. Okay, let me just give you one example. So maybe I can just write down this note. This is important. Change of units does not change. Okay, does not change significant figures. Okay, change of unit does not change significant figures. How? Let's write down an example. You can write it down as 43.2 centimeter. Simple, right? You can also write it down as 0.432 meter divided by 100. You get it in meter. Or you can write it down as 0.000432 kilometer. So you've changed the unit. Now look into the rule here. These are the 3 values. There is no involvement of 0. So the number of significant figure is 3. Right? If you consider this, you see there is a 0.432 and this 0 is, that means this value is less than 1. This value is here. So this is the rule. So these zeros not considered. This is again having 3 significant figures. And again there are 4 zeros before this value, so there is also only 3 significant figures. So they all have got 3 significant figures. So even if you change the unit, the significant figures does not change, and that is why this final rule is important. Okay, probably this was observed and then only this rule was made. I'm just guessing. Okay, but then this is important, this is why it is there. Okay, so let's just look into one problem which actually might come to your mind if you just look into this very carefully. Okay, so let me just look into one ambiguity. Okay, so there is something which is a bit confusing here. So I'll just take this. So there is something which does not add up with whatever rule we say, okay, and that is actually with terminal zeros. So the 47,000 example that I gave, and there is a terminal zero, that does not add up, okay. So I'll tell you why with terminal zeros, okay. So let's take this example. Let's say I have got 5.700 meter, okay. Since this is after the decimal point, we basically have to consider these both zeros as significant, okay, and this is 4. Imagine this, as per rule, if you are adding a value, let's say 3.1426, and you are adding a value with, let's say, 4.2, you cannot add these two values technically, okay. If you want to be mathematically correct, what you have to do is you have to take three zeros here, and then only you can go with the addition, okay. You should have some value below these, and then only go for addition. So usually we put 0 0 0 and then do the addition, okay. And that is why these zeros that we put after the decimal point plays a very important role in understanding significant figures, okay. But then if I just change this unit, let's say I want to change it to let's say centimeter, okay. So centimeter would be nothing but 570.0 centimeter. So that will be again four significant figures, okay. But then if I just want to convert into millimeter, what happens is this, check this now, 5700 centimeter. I will just multiply it by 10, and this is millimeter. Now if I go by the rule, these zeros are not after a decimal point, this is with the value, okay. This is a whole number. So what the significant figure is just 2. Now, just now I said that with change of unit, the significant figure does not change. Okay, and that's why this does not work sometime, and that is why it is called an ambiguity. Okay, so what happens is usually whenever we are converting in such cases, we usually write it in this way: 5.700 into 10 to the power 3 millimeter. And now this part is not considered as a part of significant figure, this is considered. So this is having 4 significant figures. So this is how we resolve it, okay. So this is the question mark, and how to resolve, how to resolve, okay. So this is how you resolve it. So think about it in this way. Sometimes when we are doing any kind of numerical problem, let's say I'm using the value of charge of electron, and I take it to the power of 19 minus 19. Oh, sorry. Yeah, power of minus 19, right? 1.6 into 10 to the minus 19. And then you are going to add a value, okay? Let's say that is having a power of 10 to the power minus 18. What we usually do is that value which is there with 10 to the power 18 minus 18, I change it to 10 to the power minus 19 and then do the addition, okay. So we feel that okay, this is convenient, but you know, as per rule that actually should be done, and this is one of the main reasons why we do it, okay. So this is one of the ambiguity which needs to be removed, and it can be removed by raising the value with powers of 10, okay. So this is important, so please consider this. And there are certain notifications or notations that we should all be aware of, okay. So let me just write down some scientific notations. These notations are something which are used, okay. If you are following any kind of standard book, you basically see that they will actually use these notations, okay. So if we just write down a number, okay, we can just write it down as a into 10 to the power b, okay. A and b are some numbers, okay. And what is usually these values, okay. So this exponent b, this exponent b is an integer, okay. Please remember this. This is usually taken in this form, okay. And coefficient, basically we basically call the a as the coefficient, okay. So is any real number, any real number, real number called, now this is something which is new, a new term, significant, significant, okay. So it is not SIGNIFIGANT, it is FIGAND, okay, significant. So that is the scientific term, okay, whether you use it or not, that's totally up to you, okay. Usually these things are not used that much regularly, but then I think this is important to know that what is the notation that is being used, okay. There are certain rules for significant figures, okay. So there are rules of operation, and then I think since I'm doing it, let me just complete it, okay. Rules for operation with significant figures, okay. So what happens usually is this. Let's say I want to multiply with two values, okay. So I will just give you an example. Probably I won't write down the sentences here, okay. So this is the first rule that I'm taking, and I'm just explaining this with an example. So suppose I have got a value 5.879, okay, and you are going to multiply it with a value of, let's say, 4.65. You can put a 0 and then do the multiplication, that's fine, okay. There are four significant figures here, and you can see there are three significant figures here, okay. So when I do the final calculation, I will probably get an answer something like this. You can just check. So the 27.33735. The question is this correct? The answer is no, it's wrong, okay. This is not the way that we are going to write it down, because out of the two values that we are multiplying, one of them has got three significant figures, one of them has got four significant figures. So the final answer should be up to three significant figures. So since there is no question of rounding off at the first decimal place, because this is uh, 5 or less than 5, right? It's less than 5. So basically we just write it down as 27.3. Okay, and this is the correct way to write it, because it has got, or I think this is the correct way of writing it, because it has again got three significant figures, and that is how we write it down, okay. So whenever we are doing any kind of numerical problem, we kind of randomly just round it off, okay. You might have an intention of doing it, okay, I'll write it down as 27.34 because I'll round it off at the second decimal place, right? But then that's not the correct way. The correct way is whatever original values you had, okay, the number of numerical values, significant figures, the final answer should also have that many significant figures, and that's important, okay. One more rule with addition here, and might be I can just write it down, just 6.121 plus, let's say I will take 7.4 plus 8, sorry, 8.123, okay, plus, okay, let's just keep it up to this. So if you just add this up, okay, it will be 21.644. If you just do the normal addition, you know there are up to three decimal places, okay. And if you just check here, it is three decimal places. This is one decimal place. This is with addition or subtraction, and this is again three decimal place, right? So the final answer should be having the decimal place, which is actually the minimum here. So this is only one decimal place. So here also we'll prefer to have only one decimal place, okay? Because you know, if you look into the significant figure point here, see, this is 3, this is 4, sorry. There are 4 significant figures here, and there are 2 significant figures here, and then there are again 4 significant figures here. So the minimum is 2. So if you consider this point here, this answer, and if you consider only 2 significant figures, that means your final answer should be only 21. Now that's not correct again, okay, because there are some significant values in the decimal place, so that's not correct. So when you do any kind of addition or subtraction, what you do is you consider this. This is important, okay, this is very important. So one decimal place, so it's only up to one decimal place. So what I will do is I will keep the 21 as it is, and then on the first decimal place I'll just write down the value, so it's 6. So this is how you write it down, okay. So that's again important. So this is only one decimal place. There are certain things with rounding off also. We sometimes have this tendency. It's 5 or more, I'll just round it off and I will add 1 to the previous value. But then there are certain rules rounding off. Okay, there are certain rules for rounding off. Okay, and these are some rules. Okay, so let me just take on again some examples. Let's say I write it down as 5.4757. Okay, so you want to just round it off. Okay, this is greater than 5, and this is simple. I'll just put it as 5.476. Okay, so just add 1 to the last digit. Okay, so I don't think I need to explain this. So when you write down in your exam, I expect that you're just able to frame it properly. If I'm able to write down in some kind of sentences. Okay, and then let's say I want to round this value 5.4752. Okay, and that it's always less than 5, so this value is less than 5, so it's very simple. I will just take it to be 5.475. Okay, so I usually don't do any kind of addition or subtraction. Okay, I'll just keep it as it is. Okay, but then what if the terminating value is 5? Okay, what if the terminating value is 5? Now this is important and this is different. Let's say I'll take it as 2.354. Okay, now this is okay. So this is uh, 2.4. Okay, but then if it is, let's say, 2.254, we just write it down as 2.2. Okay, how the rule says that if the preceding, this is something which is new. In case you didn't knew this is the rule. Okay, if the preceding digit is odd, then increase by 1. Increase by 1. So you see the preceding digit is odd, so this is 3 odd. Okay, and since this is odd, we are going to just increase it by 1. Okay, on the other hand, okay, if the preceding digit is even, okay, if the preceding digit is even, we won't leave it unchanged. Okay, unchanged. So see, this is even, this is even, so you're not going to play around with this. We're just going to keep it as 2 itself. Okay, if this is odd, we are just going to add the value. So rounding off has this rule which is ignored a number of times. Okay, and usually we don't put much importance on this. Okay, so I think this should be something which could be considered. Okay, and finally, to end this topic, maybe just take one numerical. Okay, so calculate the surface area of a cube where each side measures 7.203 meter. Okay, so you have to find out what is the surface area, but then consider it within the rules of significant figures. Okay, so you have to just do the calculation within the rules of significant figure, and that's your job. Okay.